This is problem 121 of Neetcode 150, regular expression matching. So this is the last problem of the 2D dynamic programming playlist. So let's read the problem together. We are going to be given a string S, which is going to consist of lowercase English letters. And we are going to receive what they call the pattern P. It's going to consist of lowercase English letters and also dots and stars. So we are going to have to return true if with the rules of the dots and what the stars can allow us to do, we can basically turn the string P into the string S. And what does the dot and the star allow us to do? Well, the dot allows us to basically choose every character. So this is like the Joker, right? So if we have like a string S of 5 letters, whatever the thing is, um, or 6 letters, let's say we have single, we have the word single, and we have 6 dot. Well, we can turn every dot into the correct word. So a S, a I, a N, a G, a L, and a E. So that will work. A star though will have to match 0 or more time the preceding elements. So let's say that we have basically a 3n as the string S, and the P is an N and a star. Since we have a star after the n, it means that we can use this n again 0 time or infinity amount of time. So meaning that now we can turn this star into 2 additional n to match the string S. So this might seem quite complicated. We're going to use 2D dynamic programming, and I will basically just show you the algorithm at first, and then I will show you why it actually makes sense the way it is. So with that being said, let's jump into the our blackboard. So let's say we have the string x, b, and z, and our pattern string is a x, a dot, a star, and a z. So just from this, if we use our brain, will we say that this is going to return a true or a false? Well, we know that the first two x are matching, so this is good. Then we have a b and we have a dot. So to make them match, we're going to have to turn this dot into a b. And then we have a b and a star. So that tells us that with this star, we can basically clone the previous dot, which is now a b. So can we clone a b again and have this matching? Yes, we have a b again. And then we have a z and a z, so this is going to match again. So the answer here will be true. So it makes a lot of sense when we do this on a surface level with our human brains, but how can our algorithm do this in an efficient time and space complexity? So we're going to create a 2D grid that looks exactly like this. And notice that I'm adding an additional column and an additional row. So this is done by purpose. And also notice that the bottom right cell is containing the value true. I might not have explicitly said it, but a F in red stands for false and a T in green stands for true. So yeah, the last cell is going to be a T. Reason is that we are adding an additional space on each word. And this space is going to represent the out of bound index. And the out of bound index is basically empty space, or I consider it to be an empty string. So two empty strings are exactly the same. This is why with an empty string, we can make an empty string, and we have a true value in this bottom right cell. So with that being said, we are actually going to start at this index. And the reason is that it is possible that the string s is, for example, x, b, z, and that let's say that in our p pattern we have like a t here, which doesn't make sense, and then we have a star. Well, the reason is that we want to go out of bound is basically to account the fact that since we have a star, we can actually remove this t, meaning that we will only have this pattern here, which will eventually match the string s, right? So this is why we want to go out of bound. In this particular context, it won't be that useful, but our algorithm doesn't really care whether it is useful or not. We're just going to make it do that every time. So what we're going to do is that we're going to check if the characters are matching. Um, and if they are not matching, we want to see if the next character is a star. Because if they are not matching, so let's say that we have n as a string, and our p pattern is a star, a n, and another star. So in this case, would you say that this is true? Well, technically, when we have a star, we can take the previous number and multiply it by something that is between 0 and infinity. So we can take this value and multiply it by 0. Hence, our entire p here will just become n star. So this makes it quite complex, right? Because now we know that with our n stars, we can actually multiply this n again and actually get the same value here that we have for our string s. That will be true. So how we're going to account that? Well, we have to take three possible avenues in consideration. The first avenues is that the two characters are matching. For example, here I'm drawing a few yellow lines just to show that the two z's are matching. So if this works, well, we will just like to basically move our pointers to the right. And when I say pointer, let me just draw this illustration to make it crystal clear. So this is our string, and this is going to be the pattern. So if we have two characters that are matching, like these two, what we sort of want to do is that we want to like scratch them and just move our pointers to the next value, see if they match. And basically, a value that match is a value that the two characters are the same, or that the character on the p pattern is a dot, because we can turn that in whatever value. And if the character is a dot, well, then there's another consideration to take into account, is that if the very next value is a star, well, we are going to scratch this value, but are we going to scratch this dot so far? Not yet, because if the next value is another b, well, we will like to take that dot and multiply it again, right? We want another b. And now since we have this, we're going to go see if this z can be multiplied by, well, can be another b. If it is not, we're going to scratch both. So we're going to scratch the dot and the star, and we're going to move our pointer to our z, and now we're going to see that they're matching. So if they're matching, what we're going to do is that we're moving our pointers. And what is a pointer exactly? Let's say we have these two x. Well, when we have these two x, we're just going to be willing to scratch both and go to this b and this dot. So when we have two matching characters and the next value is not a star, we're just going to be willing to go one cell diagonally down. This is what moving our pointer means. Okay, so let me just erase that. Thanks. All right, so now we are here at this place where we have our yellow dot, and we want to see if the two values are matching, or if the next value is a star. So basically, there are like three if statements here. The first one is if these two values are matching. The second one is inside this first statement. So if the two values are matching and the next value is a star, can we multiplicate this value again? And the third statement is, what if the two values are not matching, but the next value is a star? Maybe we will like to use our star to remove the value that is not matching, so this two strings works. So this is really the two things we want to do, and I'll show you how we're going to do this. So first thing we're checking is the two characters matching. We have an empty space and we have a z, so this answer is already given. No. Is the next value inside our p, which is our pattern, is this a star? No. So nothing really works here, so we're just going to move to the left, and we're going to have a star, and we're going to have an empty space, which is not two equal characters. And we're gonna take the next characters and see if this is a star. It appears to be a Z, and it is not a star. So we are just gonna move again to the left because, as you can see, we're using bottom-up approach in dynamic programming. So now we're gonna have a dot, and we're gonna have an empty space. So see that a dot can actually become an empty space. So technically, this is true. So when two characters are matching, the first thing we want to check is the character that is one cell diagonally down. But in this case, we're actually in the last row. So there is no row that is under it. We can't go diagonally down. So this is something we have to take care of. Um, and also the next character is a star. So what we want to do is basically, if we are using this star to basically delete this character, will this cell here be a true? So what if we use this star and we remove this B, for example, and we go C or two Z's? Will this work? Or like if I use this star to remove this Z, will the next character, which is an empty space, match this value here that is a Z? Well, no, right? So we're gonna put it F here, false again. So now we're gonna move to our last cell of this last row. We're gonna have an X and an empty space, they're not matching, and the next character is not a star, so there's nothing to do. So we're gonna let this be a false. So we're gonna go here. And notice that we're never gonna touch this last column. This is just an additional column we're giving us to basically add this true here that is well, crucial for this problem, you'll see later. So now we have basically two Z values, and the next value after this Z is not a star, but the two values are matching. So what we do, if they're matching, we're gonna go see one cell diagonally down, and we're gonna set this value to be this true value. So now we have a green key at this cell because we can actually complete the string if the string is basically composed of a Z on each side. Now we're gonna move. We're gonna go see this place. The two characters are not matching as we have a star and we have a Z, and the next value after the star is a Z, which is not a star again. So we can't do anything on this. We're gonna let this be a false. Now we're gonna go see the next value. We have a Z and we have a dot. So these two values can actually work because let's say that we only have, because right now we're in the row where we have basically just the C of the we just have the Z of the string S, but we have basically a dot, a star, and a Z. So this will actually work because you can basically turn this in whatever value. You can turn this into a U, and then you can use your star to basically multiply this U by 0 and end up having just a Z. So in this case, what we're doing, since the next value is a star and both are matching, well, the first thing I want to do is that I want to set this value to the value that is 2 cell to the right, because the value that is 2 cell to the right will tell me whether or not I can actually just remove this value by multiplying it by 0. So it is initially going to be set to true. But there are actually two ways, right, to have a true here. The first way is that the next value is a star, so we can just remove it. But the second way is that the two values are matching. So if the two values are matching, so for example, I decide to so what if I decide to turn this dot into a Z? Well, technically, at this specific index, the value here Z is gonna match the value of the string Z. But then I'm not using my star in this situation, so I will end up having a double Z, which is not the same as the string we're given here, or the string that we have so far inside the vertical word. So so in this case, actually the best situation will be to just turn that dot into whatever value and then use your star to make this not exist anymore. So that's what we're doing here. Now we're gonna move again. We're gonna see a Z and an X. They're not matching, and the next character inside our P is a dot, so it is not a star. So there's nothing we can do. We're gonna let this be a false. So now we're gonna go see here. two characters not matching. Next character of the P is not a star, so we're just moving. We're gonna let this be false. Now we have a B and we have a star. Are these matching? No. Is the next character inside our P a star? No, it's actually a Z. So we're just gonna move. We're gonna let this be a false. Now we have a B and we have a dot, right? Okay, so now let's take a look at this. This is quite interesting. So I drew an orange line just to see what values we have or what characters we have inside each string. So inside the string S, we have the B and the Z, right? So these two characters, because we're doing a bottom up approach, so we're gonna basically start from the last character of each strings and go up to the first one, see if they can be made up from one another. And so that's it. Yeah. So from the string S, we have B and Z, and from the other string, we have a dot, we have a star, and we have a Z. So I will let me tell you if with this string, I can create the string above. Yeah, right? Because I can simply take that dot, turn this into a B, use my star to multiply this by one time. So I will do B times one, which will be just P, and then I have my Z. So I will have this, right? So BZ is going to be equal to BZ up there. So at this spot, it actually makes sense that we are returning a true because the two characters are matching. So the first thing I want to do is that I want to try if I use my star to remove it. So what I will do is that I will just initially set my the value of this cell to be the value at the cell that is two cell to the right. So it's initially just gonna stay true. But then if this value, the cell that is just under this is a true, well, it means that if I set this value, this dot value to be equal to this p, and then I just move my two pointers, um, well, the rest of the string will still work because the value under this is a true. So since the value under this is a true, I'm gonna set this equal to be a true. And now I'm gonna move to the left, and to the left I have a V and I have an X. They're not matching, and the next character of the P is not a star, so I can't do anything. I'm gonna let this be a false. Now I'm gonna move here. I'm gonna see that I have a B and I have a Z. None of these characters are matching, and the next character inside our P, which is the horizontal word, is an empty string, which is not a star, so there's nothing I can do. I'm just gonna move. Now I have a B and I have a star, which are two different characters, are not matching, and the next character after star is not another star, is a Z. So I'm just gonna move again, and now I have a B and I have a dot. Okay, so now I have basically this part of the string S. So I have a B, I have a B, and I have a Z, and I have a dot, I have a star, and I have a Z. So what I can do is that I can simply turn this B into a B. I can turn this dot into a B, use this to basically multiply this by 2. So I have 2p, and then I put my last z. So then I get the actual string I am looking for. So this will work. And how are we going to reflect that in our graph? Well, what I will do is that I will first set this value to be equal to the value that is 2 cell to the right, because the value that is 2 cell to the right is the outcome of what if I remove this particular place. But if I remove this particular place, right? So if I use a dot to turn this into a b, and then I use my star to turn that particular b to an empty string. So I multiply this by 0. I will be having only a z, and I will have to match the bbz with my z. So this is not gonna work. But this is why the cell to value to the right is a left. But then what if I move my pointer one down? So I actually turn this into a b, and I move my pointer again. So I go see this second b. I said the cell is a true. So I will set this to be a true as well. And now we're taking a lot of time for the explanation, but I think that the code itself is pretty easy. The only hard thing to do is to actually understand why this thing works. And one of the most crucial part is to actually get this idea when you're being interviewed. Okay, but yeah, I think it will come with a lot of practice problem in 2D dynamic programming. So then the next vector are b and x with our that are not matchings, and the next value after x is a dot, which is not a star. There's nothing we can do, so we're gonna move here. We're gonna see that we have an x and a z, two characters that are not matching, and a character after a z is not a star, so we're gonna move again, nothing to do. Now we have an x and we have a star. The two characters are not matching, and the value after the star is a z, which is not a star, so we're just gonna move again. Now we have an x and we have a dot. So what So what can we do from here? Well, we can turn this dot into an x. So then you will tell me, yeah, but if we turn this first x into if you turn this first dot into an x, then you will have basically no joker to turn an extra value into a b and multiply this b multiple time, right? It will fail. But this is not what our algorithm is checking. It is just checking if we can turn this value um, into basically into this same character. Yeah, we can turn this dot into x. And then what it's going to check is going to check basically what if we remove this x entirely. So we're going to go see basically the case that is two cell to the right. And then since they're matching, because we can turn this into an x, we're just going to move our pointer back to this b. And as weird as it sounds, we're just going to pick up this true value, um, even though by changing or dot by x, we will technically have something that fails. We will still end up, well, our code is still going to end up turning this cell into a true. But it's not going to be a big deal because see on the next cell, you have two x, which are two characters that are matching. And the next value is not a star. So if it is not a star, it means that we can't remove this x. So if they're just matching, we're going to go see the character, the value that is one cell diagonally down. Because they're both matching, we can basically move our pointers. And what we are going to find in a cell that is diagonally down, we're going to find a true, so we're going to set a true here. And now notice that we just like engineered back our way to the first, the top left cell. And this top left cell is actually going to tell us every time whether or not we can make the string with the p. So let's go ahead and code this. First thing I want to do is that I want to create two variables to hold the length of my two strings because I don't want to create, I don't want to write len s, len p every time. So I will set m to be the len of s. I'll set len to be the m to be the len of s, and I'll set n to be the len of p. And now I will create my DP, which is my 2D grid. I call this DP for dynamic programming. And I initially want to have falses everywhere. Okay. Now I will decide with this multiplication sign the len of a single row. And a single row in my example was the len of the p word, which appears to be n. And notice that I was adding an additional column. So I will just say n times n plus 1. And I want to have basically ith of the len of the word s. So I will basically use the len of s to create, well, to put inside my range here. So the range is basically len of s, which is m, but we want an additional row, so it's going to be plus 1. And also we are setting basically the bottom right cell to be true. And the bottom right cell is going to be at the last row, which appears to be at the index m, and at the column of the index n. So this is going to be equal to true. And now we can start our for loop. So I'm going to say for I in the range that will start from the very last row. The last row is going to be at the index m. And I want to do this in a reverse order up to the index 0. So I will say -1 for reverse and -1 to the bounding index b -1. So we can go up to the index 0. All right, so now I need my second loop for basically to loop through every single column inside every single row. So I will say for g in the range of n-1 because we don't want to touch the last column. It just basically, it is just there to allow us to create the bottom right cell that is holding the true value. So I'm gonna start this at n-1 and I want to go up to the index 0. So I will bound this at the index -1 and I will basically tell the for loop to be in a reverse order with this last -1. So the first thing I want to create, well, there are a couple of things I want to check. Okay, so the first thing I want to check is basically, is there a match? And the next value, so next val is a star. Okay. What if, and I will first say, what if first value is, so what if there's no match? No, there's no match, so the two characters are not matching, but the next value is a star. Okay, so no match, and next val is a star. So this is the first case that can happen. The second case that can happen is if there is a match and the next val is a star. And let me just put this is a verb here. Okay, and the second case I want to take into consideration is what if there is a match, so match, and not a next val. Wait, what if the next val not a star? Okay, so um, for um, for the purpose of being efficient, I will actually create my if statement inside a variable. So I will say that match is basically if the string s at the index I, which is the index of the row, is this equal to the string p at the index g, which is the index of the column? Or basically, what if the p at the index g is equal to a dot, right? So if it is equal to a dot, it won't really matter what the other character is in the string along the string s. It will work. So this is my match. So now I can basically use this everywhere, so I don't have to write it twice, because there's actually two ways I want to see it. I want to check it basically if there's a star after this, and if there's no star after this character, this is another place I want to also check if there's a match. So I will need this pretty often. So I will just set that to be equal in a variable that will now hold true or false for every single position inside the grid. And now I want to check if this next value is a star. So if um, basically p at the index g plus 1, if this is equal to a star, so this is good. What we are doing when we know that the next value is a star, the first thing we want to do is, what if we actually take this next value stars to multiply the current character by 0, so we just like remove it. Well, in this case, we're gonna go see the character that is two cell to the right. So what if we just skip this character? Can we actually form the word if we go see the character that is after the star? So if the next character is a star, well, we're going to be willing to check whether or not we can form the word by taking the character that is after the character after the star. So the dpi at the index g here is initially going to be equal to the dp at this same row, but at g plus 2. And why g plus 2? Because g plus 1 is the star, so the character that comes after the star is going to be this character we're looking for to compare. So though this might be true, it might be false, but we know that if the two characters are currently not matching, well, this is our best luck of potentially completing the words, because if they're not matching, we can potentially use this star value to basically multiply our current dot by 0 or current character by 0. And so we're going to basically take a look at the character that comes after the star to see if it starts matching till the rest of the sentence. So this is the first thing we're checking. But now if there's also a match, right? Well, we want to set the dp at this I and this g um, to be true if the cell that is under it is a true, right? So it is possible that the cell that is basically after the star, so this thing here, it is possible that this is a false, but the cell that is directly under it is a true. For example, I'm thinking about this example where the two x are matching. Once they're matching, what we do, we just move our pointer, so we don't take a look at these anymore. So we're gonna go see this p and this dot, and then we can actually turn this p into a dot. So what we want to do is that we want to basically, we don't want to move our pointer from this dot, but we want to move our pointer from this b to check the other b, see if it will actually work if we multiply this b by another cell. So that being said, if there's a match like this match here, and there's a star on the next character, I want to take a look at first, should I actually remove this character with my star, or should I go down to actually multiply this character one more time? So there are two ways to get a true in this cell. So this is why if there's a match, I want to set the value to be true or false. True if any of these two options ends up being a true. And I will do so by comparing the value that we get by seeing, by basically using our star to delete this character, or the cell that is one cell down. So at the I plus one and at the same column. So at the column G. Great. So now we did basically this scenario where we have a match and the value is a star. We did a scenario where we have a match and the next value is not a star. Now, what if there's the next value is not a star, but there's a match? So after if statement to see if there's a star, we're gonna have another elif statement to see if there is a match. So if this fails, but there's still a match, what we're doing is that we're gonna take the dp at this I and at this g to be equal to the dp that is one cell diagonally down. So it's gonna be I g plus one. Whoop, plus one like this. And notice that here in our first if statement, we're gonna go take the value that is two cell to the right. So it is possible that we get out of bound. Just to ensure that we're not reaching this region, we're gonna first check if g plus one is this smaller than n. Okay. And also here, when we have a match, we're gonna go see one cell diagonally down. So we have to ensure that there is actually a row that is that is that exists under it. So what we're gonna do is that we're gonna say if I is actually smaller than m. Okay, and that's everything. So now we can return the dp at the index 0, 0. And if I did everything right, this code should work. And I actually forgot for I in. I went a little bit fast here. I apologize for this. Let's test this again. And that it worked. Awesome. We can speak quickly about the time and the space complexity. For the space complexity, which I think is the easiest one, you can see that here we are creating a dp, which is basically n times m, where n is the len of p and m is the len of s. So you can see that we're going to have a memory complexity of n times m. And for the space complexity, we have two for loops. And one for loop is going through the len through every single characters in the len of m, and the other for loop is going through every single characters in the len of n. So we're going to have a time complexity of big O of m times n. All right, so with that being said, I hope you enjoyed the video, and I hope to see you in the next one.